Um, Alrighty guys, so this is a simple example for first order linear differential equation. You might not see it because it's not explicitly in this form, the first order linear form, which is y dash plus f of x y is equal to g of x. This is our first order linear equation form, and we have to try get this equation into this form. So let's work on it. So writing the question again in our side, let's write it in the top right corner. Du on dx is equal to u over x squared plus 1. So now what you initially might be thinking is to cross multiply, but that doesn't work. And you can't just flip it. Like, you can't just flip the right hand side because that is also unethical, because that doesn't make any sense. Because if you flip the right hand side and make it x squared plus 1 on u in the hopes that you can then make it separable by multiplying these two, well bro, you have to flip this too to keep it constant. So it's dx on du, and you're in the same situation as you started off. So I guess your best course of action would be to divide both. You could go this way, sure. Divide both sides by 1 on u. So du on u is equal to, and you can multiply both sides by dx. Dx on x squared plus 1. Sure, you can do this. It is separable. But there is a much easier method, and that is using the integrating factor. So what you're going to do is, you know how the question said dy du on dx is equal to u over x squared plus 1? What I want you to do is, this is just u dash already. So let's just write it here. U dash is equal to, so look, let's write our required format. Required format is this y dash plus f of x, come on, y is equal to 0. Easy. So now u dash is equal to u over x squared plus 1. Okay, then I guess you could bring this to the other side. Minus u over x squared plus 1 is equal to 0. And well, this is just u, that's the variable we want, so I guess you can take it out. So that's u squared minus 1 over x squared plus 1 u. It's the same thing, I've just explicitly shown that I'm multiplying the u in. But then it's a minus here and it's a plus here, and sure, although it looks like we're almost there, let's just get it in the plus format too. Let's just send this plus inside. Minus. Okay. Now it's truly in the form. This you can take as fx. And yeah, it's in the form that we like. And 0. What is a 0? The 0 could be g of x. That is no problem, no issue at all. So then what we realize is it's u squared plus negative 1 over x squared plus 1 u is equal to 0. At this point in time, let me just delete and rearrange. Okay, at this point in time, what you realize is that this is your f of x. And you know how integrating factors work, right? Integrating factors work by taking e. See, if integrating factors, the way they work, if, is that you take e to the power of this px or this fx dx, and you integrate it there, and then you multiply everything in that equation by that power. So then here on this side, integrating factor e to the integrating minus 1 over x squared plus 1 dx And this is when you realize that you have to actually refer back to your inverses. Remember that sine inverse plus c. Do you remember what that is? Remember secant inverse plus c and tan inverse plus c? Let me show you my way of remembering these. So when I see sine inverse plus c, right? I'm usually thinking, okay, there's a sine here, there's a s here, and there's a s here. So that stands for square root. So everything is a decimal, all base 1. So, but except there's a square root just for these two. And sine is positive. No, sine isn't positive. Both are negative in the middle. Hey, yo, what happened? Okay, that's cool. Looks like my what is it, guys? Looks like our this thing just ran out. Yeah, sorry for the slight delay. Looks like my Apple Pencil just died. It's all good. I'll reboot it. Think about this for a while, because it's really not that hard. Because look here, what I'm saying, let's talk for 1 second. But for sine inverse, treat the s as a square root, and they're both negative because the tan has to be a positive. Why? I'll explain. See how the tan, the t in the tan, it looks like a plus, kind of. Exactly. So assume that there be a positive there, and then it's just going to be x squared plus 1. And now what's the catch here? It's 1 minus x squared, and this is x squared minus 1 with the xa. So then this is just secant x, absolute value. Yeah, sine inverse of what? Sine inverse x. So this is your integrated terms. And this is how I just briefly remember it. I just wanted to showcase this because 1 over x squared plus 1, 1 over x squared plus 1. Yeah, exactly. This is just, see, this is why I like the pencil. We wait a couple of seconds, right? And it'll go up in like extremely fast. Like, look at this. We're at 20, 21, 22. Exactly. It's like it goes up every second. The Apple Pencil charges so fast. So let me wait until it goes to 25. Okay, this is good enough. I removed it. Stop charging. Now let's start working. Okay, then if you integrate it, yeah, it's just, bruh, I just deleted you. So then this is just e to the negative tan inverse of x plus c. But apparently the plus c is redundant and useless later on. So now apparently if I multiply everything by this term, I should magically just be able to solve this. So u squared u dash into e to the minus tan inverse of x plus 1 over x squared plus 1 u e to the negative tan inverse of x is equal to 0. You're like, alrighty, that's fair. And now if we simplify this further, yeah, when you simplify this further, right, when you take it as u e to the negative tan inverse of x, and you product rule it, because all these questions comes down to a product rule technique. Okay, when you product rule this, right, equals 0. When you product rule this, what is it going to be? Keep diff the first, u dash, keep the second the same, plus keep the first the same now, and then diff the second. So when you diff the second, you get this as is into, well, you gotta diff this, you gotta diff this too. And what happens when you diff tan inverse? Well, when you diff tan inverse of x, you're gonna get 1 over negative x squared plus 1. Because negative just carries out, and tan inverse is just 1 over x squared plus 1. And that is what you're gonna get. And we notice out, oh wow, 1 over x squared, wow, similar terms. Yeah, what you notice is you're like, wow, similar terms. Oh, times u, similar. E to the tan inverse of x, e to the negative tan inverse of x. Wow, they're the same thing. Wow, they're the same thing. So you're like, wow, this really does work, because that really does add up to 0. So then you just continue working. I think I should just scroll back a little. But yes, this is just product rule. So this is just the u into the integrating factor diffed. Okay, so that is equal to 0 already. And then if you integrate both sides, u e to the negative tan inverse of x is equal to the integral of 0 dx. And what happens when you integrate something like 1? Well, you get x. When you integrate 0, do you still get x? I don't know. So 0 plus c. Okay, cool. And then we want u. So u is equal to 0 over that, and c over e to the negative tan inverse of x. But then apparently it's not this. Apparently they can just bring it to the top. But this is how you solve this question. Thanks for watching.